Hi everyone, this video is going to be about something called UWB, which is ultra wideband, and it sounds very, well, very much of a nothing really. Ultra wideband, wideband what? I mean, we all say wideband, broadband and all that, doesn't really mean a great deal. But UWB is ultra wideband, and it's a similar technology to Bluetooth and Wi-Fi and those other ones that are becoming, well, we're used to them now, we use them every day, don't we? But this one's called ultra wideband, and it's fairly new really. It's not used widely, but it's certainly very interesting. So the best resource that I could find to get some basic knowledge about what UWB actually is this website here called antonova.com. So it says ultra wideband is a short-range, high-bandwidth wireless technology that offers precise positioning and tracking and highly secure communications. It's become increasingly popular in light of its implementation in such things as Apple's Airtag and BMW's digital key. It's driven curiosity from companies worldwide that could benefit from its features. And then it goes on saying about what its applications are and why it's good compared to other things. So it says here, for example, it says a solution to poor position accuracy with other network types such as Bluetooth, and to help revolutionise the way in which we can locate and measure distances using wireless technology. So as you can see here, it's kind of about distance really. It's secure, it's about distance, and it's a wireless technology. So you can see why it's been used in the AirTag and the digital key. So what are we up to? Radio waves, blah blah blah. Right, related to the 6 to 9 gigahertz range of the spectrum. I'm not sure if that's the United States or the EU. In the United Kingdom, we of course aren't in the United States, and we're not in the EU either. We're kind of related to it in a way, but we're not attached to it. So I don't know if we have our own spectrum. That may well be the case, but I think probably we're going to share with the implementation that the EU has. It says it requires antennas with small ground planes, which enables compact designs and applications, and they are actually very compact as well. So I've got 2 of them. Right, so like I said, I've got 2 of these devices, UWB devices. I've got them from Reyax. Reyax gave them to me with a few other modules, and this is the one that I have here. It's called RYUW122_Lite, and it's an evaluation board. There are lots of details there, but I won't bore you with the details because it quite frankly doesn't matter at this stage. It's a 3.3 volt device, which of course does matter because you don't want to fry it. Frequency range, blah 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 blah, doesn't matter about that. The anchor mode current, 8 milliamps. 8 milliamps! That's crazy. So it pretty much doesn't consume anything really. Well, of course it does consume something, but 8 milliamps. Now that's interesting because if I just get a calculator, let's say the average 18650 is 2000 milliamps. Divide that by 8, and that is 250. So yeah, that's quite good. So 2000 milliamps capacity. Well, hang on a minute, what is that though? That's per hour. So yeah, these are all per hour. So 250 hours, I think I'm right in thinking. And this here, tag mode current. Now, I'm not sure about that one. I'm not sure if that consumes that all the time or only when it's transmitting. I think it might do it all the time. So, but that's okay. So 2000 divided by 81. 24 hours. So a battery could get it working for 24 hours. That's if I understand it correctly. Anyway, sleep mode current, the baud rate. Now the baud rate matters as well. The weight, all that sort of stuff. What else we got here? Smart algorithm and high quality UWB. All of Reyax's stuff is high quality. I've had it before. In fact, you might remember my long range transmitter and receiver video. It's there somewhere. It was very good quality. Anyway, it's good for secure and precise distance measurement. Okay, but It's not really, I don't know, you wouldn't really want to use it for a tape measure sort of thing because it's not precise enough. But yeah, I get what it's saying. So we also have two documents here. These are the specification documents. This one's important. It says here the pinout. Now I haven't actually shown you them, have I? But I'll show you now. So I have one. There's my one there. So well, I actually have two. Is it going to focus? There you go. So I've got two of these that Reyax gave to me. I've just got it on the end of a USB to serial converter, which you can see there. I've wired it up according to this document here, which is really, really simple. Again, with the Reyax modules, they tend to have a really good microcontroller on them that controls everything really. So all you have to do is just communicate with the thing. You don't have to do anything fancy. It's serial communication, so it's really, really easy. So I've set my two up. There's the schematic there. Not that you're going to need that. And all you need now is really the commands. So what I'm going to do now, I'm going to plug both of them in. Oh, I'll talk to you about this as well actually. I've actually got both of them plugged in. I'm going to reset them and I'm going to show you them working in a minute. But let's have a read of this. So it says the notification of using AT command. So it can be set as an anchor or a tag, which we'll go into in a minute. The distance value will be output through the anchor and the data transmission can be bidirectional. A bit more on that in a minute. You must use AT mode command to set the module as an anchor or a tag. Use the network ID to set the network group. And this is really where we're getting into security stuff. If you're not in the network group, it won't communicate. AT address to set a unique address for the, whatever you want to call it, the tag or the anchor. The PIN, so it's got an encryption password, again more security, so if somebody does find the network, they can't necessarily communicate on it without the password. So if you want to transmit data to the anchor from the tag, you must type in that, and likewise the opposite if you want to transmit the other way around. When tag is set to the parameter of tag D for power saving purpose, the AT plus tag send and that under the anchor must match the RF duty cycle of the tag. Now, I'm not sure what that means, but hopefully that's not going to be set because I want it to just be easy, at least to start with. So tag D, what's the default? Let's have a quick look. Tag D, what's the default? Well, hang on a minute. What about it's power saving mode? Hang on, we need some more information on this power saving. Where does it say that now? Power saving, right? Power. So I want power saving off. There's nothing, no more mention of that. But okay, that's fine. Let's have a quick look at this diagram. The diagram shows an MCU. Anchors and tags. So the anchors, it looks like to me, are designed to be sat in a certain place maybe, and the tags are the things that move around, or at least that's what it's showing on here. Now they're illustrating here that there are different networks, so there's a network here and a network there. I can see that because of the network ID. So these anchors here connected to this network ID are not going to be communicating on that network ID. So they're separate networks. I think that's what it's trying to show there. If the network ID or password is different, it cannot communicate. Yep, that's fine. And then it's showing the tags. It's showing the tag moving, and it's moving and getting closer to different anchors. The anchors, it says on here, or no, it's the other way around possibly. Oh no. So the anchors are sending the tag some data, and the taggers are responding, and then the distance gets calculated. Okay, that's interesting. Alright, so time to start. Okay, so if you're going to copy off me here on my example, you need two of the modules. You need a USB to serial converter, which I've shown you. You need to obviously connect it up according to the guide. which is not hard. I was going to say not easy. Then it's very easy. It's not hard. 4 wires. Make a note of your serial ports and all of that sort of stuff. Make sure it's all powered on and all of that. Now I've got 2 of them connected to my USB to serial devices, and now I'm going to try to communicate with them and set them up. So let's see what happens. Port and port. So port needs to be 115/200. That's the default according to the guide. This one can be number 3. Let's open that. This one we want to be number 6, I guess. Let's open that. So we've got those connected. Now, capture pins and send. Let's go to send. First thing I want to do is just see if it's communicating with me. Oh, we need carriage return and line feed as well. Okay, that's responding. Are you going to respond? Yep. So both of them are responding. So I think I'll actually just reset them. Reset you, just to be sure that I'm starting from the start. Now, if we go down here, there's an example of how you can get them to communicate. So this is going to be the anchor. AT mode equals 1. So you're anchor, right? You're going to be mode 0, which is a tag. Yeah, we're happy there. The network ID, I'm going to call the network Anthony. Well, let's keep it all capitals. The network ID is going to be Anthony. So this is to make sure they can communicate. Network ID Anthony. Okay, they're both on the same network now. The address, you can be called anchor. You can be called anchor, and you're going to be called tag. You're going to be called tag. Okay, still happy so far. The pin number. So not only are they on the same network, they need a pin. Well, they don't need to have a pin number, but they will have a pin number. I'll keep the pin the same as in the document, just to keep it easier. Okay, we've got the pin numbers now. So let me just think about this. Right, there's something I've got to do here. Now there's somebody talks first, and I can't remember how it is, but let's do this anyway. The tag is gonna send something. Now I don't expect a response straight away. The tag is going to say hello. Right, I didn't expect it to respond straight away, and it should respond when the anchor sends it a message. It should respond with hello. I think that's how it works. So let's do this now. So we need to send it to tag. Yeah, so anchor sent the tag test, and it should respond with hello. Yeah, and it has. So received from tag 5 characters, and it's received hello, and it's 111 centimeters away. And yeah, I'd say so. That's about right. Now let's just change this to I'm here or something like that. Oops, what's happened there? I'm here. Now, I've not tried exclamation marks and special characters, and sometimes they don't work well on other modules. So let's see, 5, 6, 7, 8, 9. So that's 9 characters. Now, oh, what's happened there? I'm here. Okay, so let's just check. 5, 6, 7, 8, 9. Okay, so it won't send it straight away, but every time this talks to it, it should respond with that now. So it should say, I'm here. And it didn't. Why not? Okay, maybe it doesn't like those special characters. Let's do it again. No, okay, maybe take that one away as well. It should work. You see, it's still saying, let's try it again. Yeah, there you go. So it doesn't like the special characters. It probably does say in here somewhere that you can't You can't send special characters. No, it doesn't actually, but never mind, that's what it is. So it says 114. Now let's just get this right here. So this is the message that it responds with when it gets something sent to it. So this is the tag. So what should we say just to make sure this is working? Let's say I don't know, XYZ123, and that's 6 characters. XYZ123. Okay, so that's what it's going to send back. And let's say hello. So we're going to say hello to the tag. Hello. Yeah. XYZ123. So that's as expected. Now, do you see there, without actually doing anything at all, it's giving us the distance. The next thing I want to do is, if I can, move this closer and see what it does. So I'm going to actually bring the module closer to it now. I hope I don't disconnect it. So I would say that now it's actually through a piece of wood as well. But I would say, let me have a think. That is about 50 or 60 centimeters away. So let's say hello again. Yeah, 52 centimeters it's saying. Now let's pull it further away. Like I said, I don't want to pull it too far. Oh, there's loads of slack on that. Let's pull it too far. And let's pull it over here. Right. Now it is, well, 1 to 2 meters. Well, I would say that's 1.9 meters, something like that. 1.5, yeah. Oh, it's confident, look. Yeah, it's confident. Let's move it a bit closer. Yeah, look. 86. I'm going to put it right up to it. Okay, so where's the little device? There it is. Now I would say it's just a couple of centimeters away. Let's see what it says. 0 centimeters, yeah. Let's put it right up to it. 0 centimeters. About 5 now. 0? Yeah, I would say that's about 15, 20. 20, 19, 26, 29, yeah, I would say that's... I'm going to put it through, I'm going to put some, yeah, I'm going to put it the other side of the printer. Now this printer is about 40 centimeters, I'm going to put it the other side of it. So I've got the modules either side, so it should be about 45, I would say. 63, so yeah, so I would say that's about 10 centimeters out, but that's not bad considering that all that stuff's in the way. So every time you send it, this little thing blinks. Look, ready? See a little blink there. 1, 2, 3. Yeah, so that's really cool. Now, regarding the applications, I don't know what I could use it for with Arduino, but it's certainly very interesting. I wonder what it is now. 79 centimeters. Yeah, so obviously the first thing that comes to mind is that it could be part of a measuring device, but it's actually not accurate enough for that. Although it is very accurate, it's far more accurate than Wi-Fi and it's far more accurate than Bluetooth, but it's not accurate enough to be a sort of measuring device. It's certainly very interesting though, but there are things that are good about it. So this is what it does, right? It tells you the distance. It tells it's secure and it's wireless. So whatever you can think of, that would work for that. Now, a cool thing that I could do is to attach this to my laptop and then see if it can communicate around the house. But it did say around here that the maximum distance, where does it say? I think it's 100 meters, which actually is quite impressive. Distance. Oh look, there's a calibration as well. Yeah, that is really interesting. So you can calibrate it. Now does it have... Oh, it says location to an accuracy of 10 centimeters. Where does it say the distance? It did say here somewhere. $100 meters, yeah. 100 meters on an open field. Yeah, so that is quite an interesting device. 100 meters. How big's my garden? I think it's... I can't even remember. I should remember because I had an Ethernet cable. I think my garden might be 20 meters. Anyway, so I thought I would show you the modules, and I have done. So I hope you enjoyed the video, and thanks for watching. If you have any questions, just put them in the comments, and I'll see what I can do to answer them. Thanks for watching. Bye.